How many of you have already built something with Flutter and Firebase? Okay, so pretty much knowledgeable, everyone. Are there any person here that have struggled by building something with Flutter and Firebase, or that is aiming to but never tried? Maybe. Yes. Okay. Some. They're hidden hands. Okay, great. So let's get started. Here's we come from far away, so it's not so common here in this European event. But we are Tomas and Bettina, and he's going to present himself. But we come from Uruguay, or Uruguay, depends on the accent you stress the U, how you stress the U. So South America. South America. Yes. So if you don't know, we're near Brazil and Argentina. They're on the south, far away. Yeah, near big ones, huge ones. So we came here to give our insights about how to build scalable applications with Flutter and Firebase, and we're here to share, like, we're mixing together because I'm the Flutter lady and he's the Firebase guy. So I'm going to present myself. I'm Bettina Carrizo. That's how you name it in Spanish. I'm a Flutter engineer. I'm now a self-employed or freelance, how you name it. But I've been working with Tommy for long. So in his previous company and BGB for a couple of months. And this year I started a new journey of being self-employed, and so far it's great. So yeah, that's me.
Does this work? Okay, great. And I'm Tomas from Uruguay as well. I expect all of you to know geography. I won't assume you don't know where Uruguay is.
Sorry.
But sometimes I need to assume that people don't know. So I've been working with Firebase for quite a while now. It's been years since I started working with it. I think the first Firebase product that I tried was real-time database. Actually, for those of you who don't know the story, Firebase started off as one product only, which was its real-time database. Before being part of Google, then Google acquired Firebase and they started to add more and more products. So Firebase stopped being a one standalone product and became a platform. That's how Google calls it, a platform for building apps. And they started adding new products, and Firebase became this suite of different products that you can leverage to build your own web or mobile apps. So I've been a Firebase Google Dev expert since a couple of years now, maybe. I also work as director of engineering at Very Good Ventures, focusing on everything that surrounds Flutter within the company. I'm also organizing GDG Montevideo. So anytime you pass by Uruguay, make sure to let me know and we can set something up. And after doing some introductions, and obviously make sure to connect with us via Twitter or X and via LinkedIn as well. We're going to start talking about what are we going to do in this workshop. And I'm seeing that most of you have already opened your laptops, which is fantastic. And if you haven't done that, I encourage you to do so. For those who don't have laptops, don't worry. You'll still learn a lot from this, and you're going to still be able to access the code later and do it asynchronously and not in real time with us. But let's talk a little bit more about the workshop. So the first goal, obviously, learn how to build scalable Flutter apps using Firebase. Most of you have already used Firebase, so we'll dive into probably more advanced topics, especially the newest Firebase product that was announced a month ago during the Google I/O, which is Firebase GenKit. We're going to see a couple of instances where we can leverage this powerful tool and make the most out of our app. Also understand best practices for ensuring security in our applications and discover strategies for managing costs effectively. Who here who has used Firebase is a little bit concerned about the costs of using Firebase or Firebase blowing up your wallet? So some of you are. Okay, great. So I've heard this question repeatedly, more than once. And people sometimes assume, hey, so I'm building this MVP, Firebase is good for now. And whenever I reach thousands and thousands of users, I'm going to transition to something else, right? So that might not be necessary. Sometimes Firebase is used in not the best way. And we sometimes see blog posts of people saying, okay, I spent like $20,000 with Firebase because I messed up this and this happened. So if we learn how to use Firebase properly, the way it's intended to, and we use some techniques, we are not necessarily going to be blowing up the costs of Firebase. But Firebase is not the magic solution for every scenario. And we actually chose this topic here and the app that we're going to show next because there's one scenario in which the current Firebase stack of products is not going to be the most suitable, but then we're going to talk a little bit about a new Firebase product that might help us in the long run. So what are we going to be doing today? Let's take a look at the app we're building. And I'm going to play this little video here. So this app that we built is going to be showcasing Flutter plus Firebase, and we'll be reviewing the app's main features, then talk about the different Firebase services that we're using, and then dive deeper into the code base. So there's a little sneak peek here of what we're doing. And in the next slide, I'm actually going to be passing this to Betty so that she can talk a little bit more about this because I think she will be more identified with the topic that we're picking for today.
Okay, so I don't know in your country how things are, but I figured out that here is not quite same. But in Uruguay, we tend to see many people like buying dogs with breed, so they're like real breed dogs. I don't know how to say it, but you get it. So they are used to match their dogs with the same breed, okay? And you have to find a suitable couple that also is not nurtured, so they can have baby dogs. But also there are people like in the neighborhood I live, there are many people with dogs. Like you go to the street and many people are walking their dogs, and it's pretty common to have mates for like the owner of the dog, and then the dogs know each other, and then you have like a new friend because of the dogs that you have. So I have a pet. 10 months ago, she was born, and I got a lot of friends in my neighborhood because of her. Otherwise, I wouldn't talk with people. Not like that. So with Tommy, we were thinking about, because there is a real issue. So there are people with like breeded dogs that they are trying to find a couple. This is not the only case, but it's kind of the most common, and people get frustrated because they want to have baby dogs, but they can't. So we created, so this is a real sign from Uruguay. So a friend sent us this picture, which is translated there. So it says, I am seeking for a girlfriend, and this is my name, and this is the number you have to contact. And this is not the only case. I was talking with another lady I met because of their dogs, our dogs. And she was telling me that she couldn't find a proper match that was not nurtured. So that could be able to have babies. And so we were thinking with Tommy, and we say, hey, why don't we create for the workshop a Tinder for dogs? Which is not only for, of course, this situation of breeding and stuff, but also for getting to know more people and like showcasing the interest of the dogs, because if you have an older dog, maybe he doesn't want to play around, but he wants to walk, or he likes to swim, or whatever. So you get to match interest of the dogs with other person that has another dog who matches it. So we created this app, which is called Teen Dog. And we'll be showcasing the app, and we'll be showing the whole architecture it has mostly on the Firebase side, because it's the most, like, we're talking about scaling the data, of course. We're using assets here, so we're using images, we're processing them, we're storing data, but also like how it looks on the Flutter side, because we have to see something like the application live. So we'll be seeing how the app is working, and you'll be able also to play around and add more features that we have left there.
Yeah, so I encourage all of you to access the code and follow along. We're going to be first explaining a little bit about how we built the app. We're going to be showing how the app works, and then we're going to be describing and telling you a little bit more about the Firebase services that we use and we leverage in order to build this app very efficiently. We're going to be not only telling you more about the Firebase services, but we're also going to be showing some code that we built, both on the Flutter side and the Firebase side. So we decided to split this into two different repositories. For those of you who don't like that, we could have created a folder inside the Flutter repo that has all the Firebase logic, all the cloud functions, et cetera, et cetera. But yeah, we decided to split this so that we can take a look at the Flutter side of things, which obviously are using the Firebase SDKs. So it's not like in the Flutter code we don't have any Firebase stuff going on. We do. But then the code that will be running on the server side and all of our security rules and other things are placed in the backend repository. If you scan those QR codes, you should be able to go take a look at the GitHub URLs. Before we proceed, can we confirm these are correct and you are able to see the code?
Yeah.
Okay, fantastic.
Great.
So let's show some app working.
Okay, so I'll be first, and I have to switch the computer.
Yeah, this is a tricky one because we cannot connect to laptops at the same time, so we have to unplug and plug. So hopefully you didn't mind about that.
Basically, only for showing my device, which I could have configured on your laptop, but anyhow. Oh, I don't need that. Okay, so first thing, I'm going to be showcasing the app, so not code so far at this point. We'll be just talking about, you'll be seeing more of how it looks, and then we'll talk about like details of the architecture first, and then you'll see the actual code. So, is this sharing? No. I just realized that I cannot have.
So in the meantime, you can download the repositories if you want to. You don't need to worry about running them right away. But if you want to save some time and do that right now, you can do that. We're going to be explaining how to run this code, especially the Firebase one, since I would assume some of you might not have done that in the past. Maybe you're just using Flutter and Firebase with Firebase SDKs, and you don't really need to run a separate Firebase project by itself. But basically, the backend code has some cloud functions and has a Jenkit installed. So in order to run this, I personally use the Firebase emulator, local emulator suite. So I don't need to access my code that's living in my Firebase project in the cloud. And I can iterate faster and I can be more efficient with the changes that I want to do. But it's optional, right? We don't need to run this code using the Firebase emulators. And the app itself is not hooked up with the emulators, I believe, right? So it's going to be accessing the project directly in the cloud.
I mean, what was the last thing you were mentioning? The not?
I don't think that the Flutter app is using the Firebase emulators. So.
No, it's not connected to Firebase emulators. Okay, so you can see my device there. For those who don't know, or the tool, I find it pretty cool. So this is screen copy. I don't know if you can read it, but it's a pretty cool tool to install to showcase your device. So this is my real device, and I can touch it from the laptop itself. It's very cool. So we have Tindo, okay, which you've seen before a bit. And so the purpose right now of this app is, okay, you log in. We're using Google Authentication, and also connecting that with Firebase. So we're using the Google package and connecting that with Firebase. And you're forced to upload a dog. So to use the application, you have to place your dog in there. So I've already made the sign-in process, so the data is there with the email. And what I have to choose to do first is choose an image from my gallery. So because I have a lot of dog friends, I have a lot of dog pictures, but I would like to show you how we're using GenKit here, okay? Because we are analyzing the image using GenKit, and then you'll see how the process goes. So if I don't upload a dog, I can upload another animal, or I can upload something different, like a sightseeing. It should fail, okay? We're going to try with a cat first, which is, is not similar to any dog, for sure. But then I have a wolf who can be much more likely. So it says, looks like that's not a dog, okay? Please upload a dog image to continue. So if I tap again, I can choose again. And I have a wolf here. It's just, this is going to be faster. Just for the purpose that this is, it matches perfectly that it's not. So it also gave me.
Actually, the model that we're using, which is Gemini 1.5 Flash, also determines that this is not a dog, and it tells you which animal it is. We're just not showing which animal it is because we thought it wouldn't add a lot of value here. But in the response of the model, it says, hey, this is a cat, or this is a fox. This is not a dog.
Yeah, you can get more granular on that and say, okay, give me the response of what exactly the user is uploading, so I can tell the user, okay, this is this thing and not the one I wanted. So I'm uploading this one, which is not on the database, which is Charlie. I know them by name, so they're my friends as well. Okay, so we got a green check, and it's automatically passing through the next step. Okay, and this is where some part of the magic happens. Okay, if you see there is okay, what's the puppy's name? But then the breed is already filled. Okay, so GenKit returned back details of that dog. So it provided the breed, and also it provided a description of the dog. So based on the personality of the dogs of that breed, it says like, my little guy is a French bulldog and blah, blah, blah. It does intend to set a gender of the dog, which is not always accurate. Now it says like he loves to cuddle and stuff, but it could be a lady dog, and you have to change it. So you have the
and that's the model working by us, right? Like we're not applying any sort of like weird logic. We didn't do any fine tuning. We're just leveraging Gemini's power here to determine the dog's breed, size, and a description, like a random description. When we tried with the gender of the dog, it was failing miserably, and obviously, like, it's very hard to determine the gender of a dog based on just one picture, right? Like, I wouldn't be able to tell. Like, maybe some of you who know about dogs, like, oh yeah, this is a male or this is a female, but me personally, I wouldn't be able to, and Gemini struggles a lot. So we tried, and we were failing miserably, and we decided, hey, let's not try to deduct the gender of the dog. Let's just try to deduct the breed, which is quite precise.
Yes.
Right? It sometimes struggle with dogs that are obviously not from a certain breed. If you mix dogs, it will like try to guess the breed, but it can fail. The description is a nice one. It's just a random one. LLMs right now, they work really well with that. And the size, it's like 50% chance. So we decided to leave that one. But
yeah, so we had the size. It was working, but things fail. So it was like here it says what's the size. It was selecting automatically, but something broke on the component, so something to fix later. But other than that, so I don't know how it's spelled, how she spelled it. Charlie can be Charlie, whatever. So it's a male French bulldog. We're right, and now we're asking the age. I don't remember. She might have 4 years. Okay, so you can choose years and months. He's a small. I guess he's neutered. Okay. And we have to add the interests. Okay, so all details are needed. So otherwise I cannot complete the plot file. As you see, the button is disabled. So I'll say that he likes walking and swimming. Okay. Complete profile, and we get into the Tinder like homepage. Okay, where we see other dogs. Okay, we could have get more precise information here. So we have the interests, and we can of course try to match my dog's interest with the dog that I'm looking at and say, okay, this interest match, this interest doesn't match. Okay, but right now we're just seeing the information playing there, and I can just say, okay, I like India. Okay, and I'm not interested in Leo at all. Okay, depends on what you want to do, of course. So there we have Rafa. These are real dogs. Okay, we can say, okay, I would like to play with Rafa or whatever, and we have many of them. Okay, and we have a functionality that if I would like to show it to you right now, I'll have to do tricks on Firebase, because I'm the only one using this application. Okay, so I've just created a dog, and so nobody liked me so far. So nobody liked my dog. So I cannot show you the match, how the match works if nobody liked me, because there won't be any match, you know. So do you want me, Tommy, to show that as well?
Yeah.
Yes. I mean, we have plenty of time, but I like to talk. So okay. So here we have a lot of things, but
We're gonna dive deeper into this in the showing the code part.
yeah.
Right now, we're just showing the app's features, how the app works. Once we
Right now.
dive deeper into the code base, most of your questions will be answered, hopefully.
Yeah.
But in a nutshell, this is what we prepared for you so far.
Okay, so this is Charlie. Okay, I found it. And what I need from Charlie is the ID. So we have it here because it's easier to copy. So what I'll do, okay, is I'll fake that someone else liked me, as if I was using another person's device. Oh, you know what I can do? No, I can do it better. Okay, so what I'll do with Charlie is I'll change his ID. I'll set, okay, whatever. ID. So it won't be my dog anymore. So it'll request me to put a new dog because oh, sorry, you're not seeing my. So it prompted me automatically to here because I lost my dog. Okay, I'm authenticated, but I don't have any dogs, so I cannot do anything because I've changed that ID. So what I do is I'll go back and I'll set. I have my dog, which is similar to a German Shepherd, but it's not this one. It's called Katara, like the Angst legend. Where is it? Oh, did I delete it? Okay, never mind. I remember I like India, so I'll go to India and I'll set it as my dog. And sorry about this, but it's hard to. This was India. Okay, so I'll set in India as my dog, which is L0E, and I'll go to authentication. I have my email here, which is the only one. So I'll say, okay, India is my dog right now. And I'll try to find Charlie, unlike Charlie, okay? Sorry, that's LOELC6. So this is now my dog. Okay, if we're faking this. Okay, well, was not ready for that. Let's just restart it. Okay, so I now have India on my power. There's no profile set, so I cannot show you. But this is Charlie. Oh, it's not showing, sorry. Ah, yes, we're good. So we're ordering this for names alphabetical. So we found Charlie pretty fast. And if I like Charlie, so like Charlie liked me, I should get that is a match. Okay. And this is like we're going to then work on creating the chats part because it's partially around, but it's not there set. So it's like your turn to work. But otherwise, you can keep swiping, and you can keep liking more dogs. Okay. So that's the idea. If you keep swiping, should go back. Okay. And then I have like other dogs to see. I can still like or dislike dogs. And the chats, it's empty. So I have some code already, some UI built to connect, but it's not populating. So it will do that later. But basically, this is the essence of the app. Okay. So if we've been to people or many people with phones, this should be updated like more automatically because we're using streams to update the data. Because otherwise I will have to keep fetching. Any questions so far? Nope, it's good. So we can continue. You wanted to continue, right?
Sure. So now what we're going to do basically is talk a little bit more about the Firebase services that we used in order to build this.
Yes.
Give me 1 second.
I thought I needed an adapter because I only have one Type C here, and because I have a Windows, it has an HDMI already. There.
Okay, so those of you who haven't access to the code yet, no worries. Like we're going to show this slide again later. And I'll start to explain a little bit about the Firebase services that we used. So the first one is Firebase Cloud Firestore. Any of you have used Firestore in the past? Okay, most of you have. Great. So how we used Firestore. I really don't need right now to, I guess, explain what Firestore is or how it works because most of you have raised your hand. But the way that we used Firestore, first, we decided how we wanted to structure Firestore, right? What collections we wanted to use, what documents we wanted to use. And in the part of showing the code, I'm going to show you. But we decided to come up with certain collections. And we did one thing which is not super common. I've reviewed many Firebase projects that use Firestore, and that is sub-collections. Has any of you used sub-collections before? Yeah, so maybe less than half of people who have used Firestore have used sub-collections. So the way that we want to structure our data in Firestore is so that it's effective with our domain, right? And having sub-collections on nested data is a very good Firestore practice because it creates dependencies in our data and it tries to somehow not fix us using a NoSQL database, but at least mitigate the disadvantages of using one. If, like with Firestore, we don't have like foreign keys between collections because a collection is not a table. Instead of having tables and columns and foreign keys, you have collections and documents and fields and so on and so forth. So the way that we structure our data is very important, and a good structure will be able to really optimize the way you use Firestore and taking the most out of it. And a bad data structure could easily create very serious performance issues and obviously mess up with your pricing, because if you need to read a lot of documents, then that might end up costing a lot. We're going to be also taking into consideration things that Firestore cannot do. And one of the reasons why actually we picked this topic here is because we have a limitation with Firestore that we will review later, and a possible long-term solution. Firestore has a very nice real-time synchronization feature so that we can keep our data up to date across all clients in real time, which is fantastic. Some of you might have used streams in Firestore, maybe. Yeah, most of you have. But actually, no, most of you have not. Some of you have, but most of you haven't. So it will let us keep our data synced across multiple clients. It's not that each client needs to update its own data. It will be done automatically. And obviously, I've seen this also many times, which is a very bad practice, not implementing security rules. I'm not going to ask who of you have not implemented security rules, because maybe raising your hand will. Oh, there's one. Okay. So there has been some blog posts that have gone viral about leaking data from Firebase. The last one that I saw, I think it was released this year, which is a kind of big company, which I won't reveal, had a lot of its like confidential data leaked, and it was accessed publicly, and that's because it was data about its users that probably shouldn't have been saved in Firestore because we have Firebase authentication for that. But anyways, it was saved in Firestore, and there was no security rules whatsoever. So that's not a great idea. Implementing security rules for enhanced security is not something nice. It's a must, I would say. And we're going to be seeing how to do it, and not only how to do it, but also how to test those. Next.
It's pretty well. I mean, it's not hard at all to implement security rules.
It isn't.
Oh.
And not only using Firestore is something that we chose for this workshop, but I also wanted to share with you some stuff that I would like to see once you start hands-on coding in this workshop, which is efficient data fetching with Firestore. Some of the things that we did in the code right now that's uploaded follow some best practices, and some of them could be optimized, and we will want you to optimize them. One thing is indexes. Utilizing indexes to speed up queries. Did you know that Firestore has indexes? And did you know that Firestore automatically indexes each one of the fields inside a document so that it can optimize the queries? So that's a very cool feature that Firestore has. But one thing that we would need to do manually is adding indexes for more complex queries. If we are creating queries where I'm going to be filtering data by more than one field, then Firestore doesn't have those indexes created by default for us. So that's where we need to create this index, which is really something very easy to do. And actually, if we are testing our security rules, if we are testing the way we access our data in Firestore, if we don't have those indexes created, Firestore will let us know and will create a link for us. And when we click that link, we are going to be going to the Firebase console, the Firebase UI, and we're going to be able to create that index very easily. So that's why it's important to create security rules and test them, because we're going to be able to see these exact situations. For more complex queries, we can optimize these queries by ordering and limiting the data using aggregation query and also using aggregation queries. Have you ever implemented pagination when it comes to Firestore? Most of you haven't. Some of you have raised the hands. So the way that we want to do pagination is very, very simple. We just limit the data and we set an offset, right? So if we wanted to create pages that have 10 records of Firestore, we first order in the way that we want to filter, and then we create an offset that will start by 0 and the limit will be 10. The limit won't change unless we change the page size. If you are seeing a table and you want the users to be able to change the page size, that will change the limit. And then the offset is whenever you stopped, and it will always change when we change page, the offset will change. And then aggregation queries is something that I'm a big fan of. And some of them are actually new. Who from you have already used the count feature of Firestore? Some of you have raised your hands. That's great. So the count feature of Firestore is something that was announced in the Firebase Summit in the second half of 2022. And it's something that a lot of developers, maybe some of you, were asking a lot because there was not an easy way to really count data that was part of a collection. But with the count aggregation query, we can do that easily. And it will save us a bunch of not only time, but also cost, because if we are counting 1,000 documents and we use the count aggregation query, Firebase won't charge us for 1,000 reads. It will charge us for that divided by something. It's in the documentation, but it's a much, much, much lower count. So whenever we're counting stuff, we don't need to pay for the full price of reads. We just pay a fraction of the price using the count feature. So that's a pretty cool way to start counting your documents inside a collection. And then last but not least, we have batch writes and transactions. And this is something that it's very, very important to do, especially if you want to manage concurrency and you want to manage atomic data. If you have multiple users potentially accessing part of your Firestore database, updating that data, you definitely want to create transactions so that there won't be a mismatch when that data gets updated if multiple users or multiple clients are updating that data at the same time. And with batch writes and transactions, we can make sure that these operations are atomic, which means that if I'm running multiple queries or multiple writes or updates or whatever, if one of them fails, all of them will fail. So that's a way to keep the data consistent.
One example might be like if we want to delete a user, but then we have a dog attached to that user, we would like to delete everything, right? So we don't want to have that dog's file in storage anymore. We don't want to have all the dog's information itself. We wanted to remove it because we don't want the dog to show to anyone else, but the user does not exist anymore. So we will have to do a lot of updates to get that clean.
So next Firebase product that we used is Firebase Cloud Functions for Firebase. Who from here has used Cloud Functions? Well, most of you have. That's fantastic. So the way that we use Cloud Functions is pretty simple in this particular scenario. And there might be things that we want to change in the future for these Cloud Functions that we're going to be able to see next. But one of the reasons why we would like to use Cloud Functions is to offload heavy computations and background tasks to our server. Sometimes it's very easy to access Firebase data with the Firebase SDKs from Flutter, and we access Firestore, and we access storage, and we access multiple services. But some of these computations might become quite large and complex. So offloading this stuff to the server sometimes might make sense. And that's where Cloud Functions come in whenever we want to run server-side code. And whenever we want to implement business logic that needs to be centralized and needs to be secure, right? Like code that we definitely don't want any client app to access. This comes in handy when we're developing things like games, for example, when we want to manage a centralized state across multiple clients. And we don't want the client to be the owner of the state. So that's where something like Cloud Functions can come in handy. Then we have another example of real-time updates, which is in the shape of Firestore Cloud Function triggers. We're going to show actually one trigger that we implemented for this particular case that will be a little bonus for those of you who implement the chat feature. And these functions will trigger by changes in the database or other Firebase events. And then last but not least, and you'll hear me repeating this on and on and on, which is testing your functions. For those of you who raise your hands, if you have not tested your functions, then, well, your logic might be flawed. And there's very easy ways to test these functions, which I'm going to show you an example of next as well. And then, obviously, we have this fear of costs, right, when it comes to Cloud Functions. Are there ways to optimize the way that we invoke Cloud Functions? Are there ways to figure out how to manage the cost of this? Yes. So as most of you might be able to already know, Cloud Functions price comes in a combination of two different things. One is the number of invocations. So if we reduce the number of invocations, we're going to be saving costs. And one is the execution time. So if we reduce the execution time of a function, that will also save us costs. So think about functions as things that need to run on the server side, but we want to invoke as less times as possible, and we want to make the execution time as faster as possible. Then we have performance tuning. When we have critical performance things that we need to deal with, in order to minimize cold starts and optimize function performance, we can have a minimum number of instances of our functions, and we're going to see how to do that in some of the next slides. And then I included this one especially because we're in Europe, the location, right? One of your primary considerations should be latency and availability, and that is always, coupled with location. You should know by now that the default location for Cloud Functions is the United States, right? And if you're building apps, especially if your user base is located here in Europe, you might be thinking about changing that. But there's one caveat for that, which is whenever Firebase develops new products, some of these new products sometimes are only available in the US location. So that's something worth considering. And in order to determine where we want to place our Cloud Functions, we need to consider not only where our user base is, but also the availability of the Firebase services that sometimes are only available in the US for a short period of time before making them available in Europe. So one of the next things that we used in this app, and we're going to show you how to use it, is Firebase extensions. Some of you might have heard of Firebase extensions, maybe. Who have heard of this? Well, not a lot of you. If you're not using Firebase extensions, maybe you don't need them, but maybe using one will save you a bunch of time, energy, and costs. Because these are prepackaged solutions that you can use and you can deploy in your own projects. And these extensions can respond to events generated by the Firebase products that you already use in your app. So it's very simple to use. I would definitely recommend you checking out extensions, which basically means just cloud functions, which are not made by you, are made by another company. It could be even Firebase, or it could be other companies that are deploying their prepackaged solutions to the extension hub. So this runs on the server because these are cloud functions. So the code is fully isolated from the client, and you don't need to manage the code and you don't need to maintain. So some insights of this is that since an extension is a packaged solution, all you do is install and configure the extension. You don't really need to code anything, unless you want to extend the extension, but that's a very niche situation. You can reuse the same extension in different projects, so you don't need to create like one instance and then one instance. It's very easy to use, and you can explore the extensions hub to find solutions for your app or project. So I would encourage you to go to extensions. I think it's the URL is extensions.dev, and you can take a look at the extension hub. You can filter by category as well, and then you can see if there's an extension that would help you develop a feature within your app that you need to develop from scratch. We used the extensions in this TeamDoc project, and we're going to show you how we did them. Next Firebase service that we used is, of course, Firebase Authentication, which has different mechanisms for authenticating, email password, social providers like Google, Facebook, etc. We use Google in this one. You can add as many as you want, and it should be easy to do so. And obviously, you also have phone authentication. And we're going to see how we used this for best practices for managing user sessions and states within Flutter. Some tips and tips. Not a lot of people know this, but you can extend the functionality of Firebase Authentication using both cloud functions and blocking functions. Extending with cloud functions is super easy. You can trigger functions in response of creation and deletion of Firebase user accounts. So whenever a user gets created inside Firebase Authentication, you can execute a function that will do something. The same with whenever a user gets deleted, you can execute some code. For example, a cleanup if you wanted to clean your database after a user gets removed from Firebase Authentication. The creation could be a welcome email, for example. You can do that easily with cloud functions for authentication. And then Firebase released these blocking functions not so long ago. I think it was last year or the year before. I'm not exactly sure, but it's a somewhat new product that Firebase has, which is executing custom code that modifies the results of a user registering or signing up into your app. This is especially useful if an enterprise, for instance, is building a portal and they want their employees to register to that portal. And if the employees of this company, they have their a specific email address, which is like at thecompany.com, for instance, we can use the blocking functions, for instance, so that whenever a user signs up, if the user is not using an email from the company, we can block that user from registering. And all of that could be easily done with blocking functions. We don't really need to use any other sort of service or any other sort of weird logic that wraps Firebase Authentication. Just using blocking functions will do the trick for you. We are about to end the list of Firebase services that we're using, but I didn't want to end without mentioning security rules. We need to write effective rules for Firestore, and we could also write rules for cloud storage as well. I like to apply the least privilege principle, which is start by denying access to everything, and then little by little start allowing access to certain collections or certain sub-collections or certain fields within that collection. I also like to use security rules to enforce data validation, because even if I write my data validation on the Flutter side, which is a good practice, I would do it, I still want to be able to validate the data that gets written in my database directly. So we can do that with security rules. If the data is not valid, we can throw an error to the client saying, hey, the data is not valid. So if for any reason the client side validation fails, or if somebody's trying to access our backend resources directly without going through the client, this will block the writing of the data by creating or updating or even deleting data if the data is not valid. We can obviously test the security rules. We can use the Firebase Simulator suite to run our unit tests and see that they work. And that's very convenient because we don't need to deploy our security rules in order to test them. And then we can easily deploy the security rules using Firebase Deploy in the Firebase CLI. Right? We're also using cloud storage to upload the images of the dog. There's no point in me stopping here. I think this is the last one actually that I think Bettina mentioned is Firebase Jenkit. I would be super surprised if some of you raise your hands when I ask if you have used Jenkit. So I would say maybe none of you have used it, which is great because I'm going to be able to showcase it right now. And then after this workshop, if you use Jenkit, please make sure to let me know. And I can connect you to the Jenkit team directly because they will much appreciate any feedback that you might have. So what is Firebase Jenkit? Like, obviously, each one of you can go to the documentation and read what is it all about. So I'm not gonna be 20 minutes explaining what Jenkit is, but basically in a nutshell, you can easily integrate powerful AI capabilities into your apps with familiar patterns and paradigms. You can do server-side development in JavaScript or TypeScript with a Node.js runtime. Right now, Go is another runtime that the Google team is working on. I don't believe this will be supporting Dart in the near future because Google and server-side Dart is not something that you see often. You don't have Firebase Cloud Functions for that yet, and you don't have an official Dart admin. Do you have an official Dart admin SDK for Google? I don't know. I mean, you have the Flutter one, obviously, but I don't know about the admin one.
Yeah, I'm not sure.
So we are going to be using TypeScript for this Jenkit side of the workshop. If you don't know TypeScript, it's going to be very easy to understand, I promise, and I'll be here to answer any questions. The things that we create using Jenkit are called flows. So flow is just something that receives an input and provides an output and runs a model inside. And we can deploy these flows as cloud functions so that we can call them from any client app. And you can check out the Firebase blog to learn more. Actually, if I click on this, you'll see that my name shows up there. I wrote this blog and it was published on the Firebase blog with Jay, who is a product marketing manager on the Flutter side. And here we are actually describing how we used Jenkit and Gemini to build this AI-powered crossword puzzle game for the Google I/O Connect last week in Berlin. Who was in Google I/O Connect last week in Berlin? Some of you. And did you play the I/O crossword game? Okay, there was a stand there that allowed you to play the game. But the game is public, and you can access it via URL, and it's powered by Jenkit and Gemini. This game allowed you to play a real-time crossword with multiple people, and if you didn't know the word, you could get hints of that word, and those hints were generated by AI, and we built this using Jenkit.
It was actually like you would ask questions to the AI, and the AI will reply like yes or no to guide you through the word.
So there are many more Firebase services that we could leverage in this app that we are not, because I mean our time is limited and we cannot say until 8 p.m. But there are many Firebase services that I would encourage you to add to your Flutter apps. For instance, if you want to distribute your app, Firebase App Distribution works very handy. We also have Firebase Data Connect, which is the newest Firebase SQL database that uses GraphQL, and we're going to see a little bit more about that next. Obviously, Crashlytics, cloud messaging for notifications, real-time database as an alternative to Firestore, AppCheck for an additional layer of security, remote config to change the behavior of your app in real time, and Google Analytics to get to know what your users are doing inside the app. So we could add all of these services, all of these Firebase services to our app, and we're going to have a bunch of things going on inside the app that will be powered by Firebase, which is very nice. So this is something that you can also think about adding to the app. So I think we can now take a look at the code base. We know what the app does. We have already explained a little bit about the features. And now it's time to dive deeper into the code so we can understand what is going on in the background before we jump and do some coding ourselves. You want to start?
Yeah, of course. No, you got me thinking, and I believe that all the SDKs for Firebase are for Dart actually, because you can create packages. Like we have packages that are Dart only, are Dart packages, and we call Firebase from them. So it's isolated from Flutter actually. Yeah. No. So as you got familiar with the UI side of the things, we're going to get through Flutter first, and you'll see how we're handling, how we're calling Firebase on our side for all those situations. And I hope you don't get too confused. So if there is any question you can ask, feel free to raise your hand. I will increase the size of this. Okay. If it wants to. Okay, give me a sec. Okay, so I guess I cannot increase the size of the side panel. Can everyone read the side panel? Like see the architecture? So nope. So I can open VS Code because it can increase everything. So close. So and yeah, now I need the other trick. Okay. Microsoft for the win. Closing this. And closing Android and closing this. Okay. So first of all, I would like to show you like the generic architecture of the application. Okay, we're building. We're trying here. I mean, we're using Firebase a lot. Okay, but we don't want to stick to Firebase through the Flutter side. Okay, so everything within our lib pretty much doesn't know that Firebase exists, except for the initialization of the Firebase SDK. So if we go to the prospect YAML, just for you to get to know, we only have this Firebase core here, but we don't have authentication, we don't have anything, okay? So just for the sake of, okay, if we want to switch to another provider for some of the features or for new features, we just can hide them, okay, on a different package that I will be showing you. But the application basically has like base configuration routes, setups, and it has the authentication part. I'm using block as a state management. If you don't get to understand a lot, don't worry, because we're focusing on where we fetch the data and what we do with that. The chats part, sorry, which is partially implemented. There's some UI there, not showing up on the app that I have installed. The discover part is the homepage where you swipe dogs, okay? An onboarding where you fill the details, and profile that's not also, we have the feature there, but it's not built. And then just going then to get inside it a bit more. App UI is just where I left all the components, big components. So my, I'm sorry, my lib folder remains more like the smaller in size. We have less classes because we're delegating all the components to another package which holds it. Okay, we have widgets here. And we have repositories for authentication and the service, which is the one that is calling Firebase. So this one has the dependencies we need for Firebase authentication. It also has Firebase core, and in this case, it has Google signing, okay, because it's the only one we're using, okay? So this class, the auth service, is the one that actually connects to Firebase and knows what Firebase is and can handle the data that Firebase returns. So for instance, for Google sign-in, we have a previous Apple sign-in implementation there, but it never went to prod. So we're using the Google sign-in package to get the user and the authentication, okay? And then we're providing Firebase with a credential. This works awesome for mobile. So there is another method, which is sign-in with provider, that you can also call and pass a Google Auth provider, which on mobile, for instance, in Google, in Android devices, it doesn't work well because it launches, instead of launching the native prompt for setting the email, it launches the web browser, okay? So this is the better way to implement it on mobile. And then you just sign in, so you call the Firebase South, which is this field I have here. It's Firebase South, okay, we have the instance. And we call it with sign in with credential, and we pass the credential that Google provides to us, okay? And this is the way we're signing in. There are many ways of getting the current user and also listening changes. Right now, we're getting a feature with the current user ID because we're not holding actual user data. We only care for dogs, so the user is just to know that the person is authenticated and also relate the user with the dog to know where the dog is from. So you can also have a stream here. There is a listener for authentication, which is if this allows me to call it, I believe is user changes. Oh my, that's why I hate Alf. Okay. If this won't work, then never mind. Okay, there is a way to listen changes, so you can provide those. You can provide a stream and then understand what is the state of the current user. Okay. I had a microphone upgrade. Okay, way better. Great. Okay, so right now what we are doing is we're calling the future just for simplicity, but yeah, you can listen to changes pretty easy, and you're going to see how in like for instance when we fetch dogs, we're always listening to changes by a stream, because if another person submits, like joins the application and onboards a dog, then we would like to see it with the application open without needing to refresh every time we want to fetch new dogs. Okay. So this is as simple as is authentication, okay? And basically the repository, what it does for us is be a middleman, okay? The repository knows the service we're using. It knows that it's a Firebase service, okay? So it doesn't know Firebase at all. It just knows the out service, okay? And whatever it exports. And it can be it can have as much logic as you need. In this case, we're only passing through a string, which is, we're not mapping data on this case. I'll show you another case where we do. So it's basically simple. We return the signing function call, okay? So this is a simple, and we can sign out as well. There is a method sign out, and it's easy to implement it on the other side. I want to be quick because we don't have much time. So TeamDog data source, okay, could have been many different data sources, folders or packages, but I left everything on the same place. And we have the contract, let's say, where it's like, okay, this is the part of functionality we need from getting the data or setting data on the other side, so we can create a dog and pass dog data, okay? We can analyze a dog, that happens when we upload an image, okay? And we get a DTO back, okay? Which is basically a way to call like entities that are from an outer source, so data transfer objects. And we sent a file, okay? So we pass the file and we get the DTO, and that with everything, okay? We can set dog details and don't get anything back. And the implementation, this implementation, so we're in the data source, which could be called service as well. But this one knows Firebase, okay? Everything that's implemented here, it's hitting Firebase, is It's caching their exceptions. It understands Firebase at all, okay? So we have set 2 collections here. We have a dogs collection and a chats collection. This is the constructor of the data source, kind of big, but because I'm allowing whoever instantiates this class to pass the collections through in case I want to test. So it's easy because I don't depend on things inside my class. I can just update them. But if we don't, we're creating an instance of the collection. And this is for the sake of not having to convert the data every time we hit Firebase, like we can get simple JSON back. But to do that automatically, so we tell Firebase, okay, every time I call this dogs collection, okay, instance I have this inside my class, I would like you to convert the data for me, okay? So when it comes from Firestore, then I have a document snapshot, and what I do is just pass the logic of conversion here, okay? So I'll get a dog DDO because I'm hitting the dogs collection, okay? And when I send the data to Firestore, I do the opposite, okay? So I'll get a dog DDO, and I'll call the toJSON, okay? This is a simple thing. And then for the other stuff, it's simple. So create dog for us is just calling dogs collection and passing the document and setting the dog. Okay, we pass the dog ID because we already have. We analyzed the dog and we got a new ID for that dog, and then we just update it. The analyzed dog is a bit complicated, but just bear with me here. We're doing many things on the analyzed dog, okay? Because we need to first store the image, okay? So we're creating a new doc to get the ID. So this new doc is going to have an ID. We are not setting anything, but we're just getting the instance. And this is super cool. I was talking with Tommy, and he told me that whenever you do this, okay, you're kind of creating an instance of a document, but it's within your application. So Firebase doesn't charges you for doing this, okay? So for creating a new document, but I'm not setting anything like up to this point. I'm just getting the ID because I need it to do another task, okay? That you'll see that I use the new dog, and the ID to set the image. Okay, so I upload an image, and the name of the image I want to be the ID of the dog.jpg. Okay, so that's why I use it. And you can do many things with that ID before you even push a document for that ID. Okay, so at this moment the document does not exist on Firebase. I just have it locally. Okay, so then I call a method that's called putFile. I put the image on the image storage path field I create here. And it's also like this storage is a Firebase storage. If I haven't shown you, Firebase storage. So this is kind of maybe heavy stuff. We could put this into a cloud function maybe to just ease the work of the Flutter application, but it's to show you that you can do anything. So you can do many calls of different things and set everything up. And then we're using a callable to say, okay, this is called dog data flow. And when we call this, we pass the file path of the storage. And what it does behind the scene, and maybe Tommy, you want to add something, is that it gets the image and it passes through Jenkit and it analyzes and returns data back.
It's a Jenkit flow that gets deployed as a callable function. And maybe I can show you how it works.
Okay.
We're running out of time.
Yes.
But I will show you how that becomes a callable. And I will also show you how to run the flow so you can see the results of it.
So far you get the idea of stuff, okay, pretty much. I missed the repo for that last one, but it's pretty, repos also are always simple. They basically call on map.
So on the Firebase side, this is a Cloud Functions project with some cloud functions and Jenkit involved, and I'm writing the code using the emulators. I created a flow called the dog data flow that what it does is this. So first and foremost, this is how you define a flow using Jenkit. You use the onFlow function by importing from the Jenkit package. I'm not going to be going into a lot of detail here because there's not a lot of time. But if you have any questions, feel free to
reach out.
Yeah, reach out, and I will be able to explain a little bit further. But basically, what this does is this is how you define a flow. As I told you before, it's just something that receives an input and returns an output. So here's the name of the flow. Here are some HTTP options because we are doing the flow as available as a cloud function. This is our input, which is an object that will receive a file path. And here, Jenkit uses SOD, which is a library for validating data. So here it's just deciding what is going to be the input of this flow, which then translates to parameters of a callable function. And here we're receiving the file path, so the file that Betty showed that we are deploying to cloud storage. And here the output would be a schema, which we find as a dog to be an object that has 4 properties. The first one is if it's dog, so it's a Boolean. And here is whether the image contains a dog. Then we have the breed of the dog, then we have the size of the dog, and then we have the description. We used to have gender of the dog, but then again, it failed miserably, so we removed it. And here's how we basically define the flow. The input of the flow is going to be a file path. The output is going to be this schema that we just saw, right? Then there's some auth policies, which is a good practice so that our flows are not accessible by any other besides a Firebase user. So if there's not a user, I'm going to throw an error. And then inside the flow, what we do is with the file path, we get the reference to the file, which lives inside the storage bucket. We check if the file exists. If it doesn't, we throw an error. Then we get the file type. And if the file type is not an image, then we throw an error. So as you can see, we're doing safe programming here so that whenever there's something that we don't expect, we throw errors. I consider that to be a good practice. We're making the file public because this is going to be accessible to every user. We get the download URL of that image, and then we use that download URL to create this parts variable. And this part is because we are using Gemini multimodal. So if we want to use Gemini with other things besides text, we need to pass a URL in the media property, right? So we're passing an image. And here's the prompt that we're using. And the prompt is, what's the breed of this dog? Please provide a breed name. Also try to determine the dog's size based on the image. Add a description considering the breed. It should be friendly and engaging as if its owner wrote it. Keep it short. And then obviously if there's not a dog in this image, please let me know. So this is the prompt that we used. We can obviously experience with different prompts. And then we call the generate method, which comes from Jenkit. We import it here. And this generate method, really what it does is it receives the model that we want to use. And in this case, it's Gemini 1.5 Flash. We could use other models. For instance, if you prefer OpenAI versus Gemini, we could definitely import the OpenAI model. You just need to set up an API key, and then you can use the OpenAI model. You can use Ollama. You can use even your own model if you want to deploy your own model. I haven't done that, so I don't know if that works, but the framework, Jenkit, is built for that to work, I guess. So we pass the model, we pass the prompt, which in this case is going to be parts because it's multimodal. It has an image URL and the prompt. And then we pass how the output should be, right? And this is very, very useful because if we're dealing with LLMs inside our code, we want to make sure that the LLM will return a specific output. And we can define this output using code. So the LLM will return an object that has these properties. And this, to me, is the magic of Jenkit because it allows us to develop AI features within our apps with a specific input and with a specific output without us needing to parse the output of an LLM, which you could say it's normally text. And from that text, I would need to create an object. We don't need to do that here because Jenkit does that for us, right? So we can safely add AI into our app with a output that we expect, and we know that the output is going to always be like this. And what we do is basically we get the output. If the output is not a dog, we return is dog false. And if not, we return the output. And something that I commented here is if the output is not a dog, we might want to be willing to delete those files because we're not going to use them anymore. So the method is implemented, which is this one. But I just commented it out because I wanted to show you what happens, right? So I'm running this code locally, right? And I'm going to show you how to do that right now. But first, let's try it. So I'm running the Firebase emulators here. Here's my Firebase emulator suite. And I can access the storage emulator. I created that dogs folder. And here I can upload pictures of dogs, right? So let's upload this, which is a Yorkshire, as you can see, right? And then here I'm running GenKit. GenKit comes with a UI that you can use, right? And then you can see your flows here, which again, I told you it's just a function that has a specific input and a specific output and uses a certain model to generate the content with the LLM. And here in the flow, I'm going to specify a file path, right? And I can pass some auth properties, which in this case, I'm just hard coding it here. And then I think the dog is york.jpg. So let's just go here and put here york.jpg. We can run this. We can see that the output says that it is a dog. It's a Yorkshire Terrier. It's a small dog. And then it generated a description for us. My little Yorkshire Terrier, she's the cutest, blah, 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 right? We could try with multiple dogs. Actually, if some of you have a dog and you want to try, you can send me the picture of your dog and I can try with your own dog. Any volunteers? Okay, send it to me via either Twitter or email. I didn't share my email now that I think about it, but it's tpiaggio7@gmail.com, or Twitter or LinkedIn would work. I'll download the... Oh, I'm using Google Pixel Android, unfortunately. Oh, I think yeah, the MacBook should work, right? I don't think I have used AirDrop, so if somebody wants to help. But yeah, you can send me a picture of your dog and I can try with your dog and we can see if it the breed works, right? Okay, yeah, AirDrop.
Everyone.
Yeah.
You already have it.
Okay.
Accepting
Maybe I've already used it.
Anyone could send pictures or files. It should prompt up to accept it, though, I believe.
Okay. I guess I'm just waiting then.
There are many open. Oh, maybe yes. What is the name of your computer?
I guess it's just
something Piaggio, Tomas. No,
MacBook.
was harder than.
Okay, I received a photo from Mika. I will accept it.
Yay!
Save to downloads. Receiving the photo. Okay, here we go. All right, I'll just rename it here to Mika. I'll save it here in this folder, and let's try uploading. And obviously, again, as I said before, this is using the Firebase emulator, but we could use it with our Firebase project in the cloud, right? So let's select Mika here. Oh, what a beautiful dog. Okay, let's get the URL. Let's run Firebase GenKit with Mika. There we go. Let's just run the model. So the British Labradoodle, is that a thing? Okay. Size medium, and then meet my adorable Labradoodle, and that is Mika, right? So as we can see, the model is working like as expected. And just to wrap it up, because I know you're probably hungry and you want to go eat something, that's what I want to do as well. Some actionable tips for your projects, right? So for scalability, efficient data modeling, we have already mentioned that, indexing strategies, multi-regional locations, and you can also use Firestar as offline mode if your app runs out of internet for some reason, and obviously use cloud functions. For security, strong authentication, least privilege access control, effective use of security rules, testing your security rules, And then for cost management, optimizing read and write operations, monitor usage, set alerts. Here you can see very quick that I have in my code my security rules. So you can see it here. If I open Firestore rules, you can see that, for instance, I have a method here, which is if it's a valid string, a function that returns true if it's a valid dog, which checks for the name of the dog, the breed, the size, and the description. And then here in this dogs, I will only allow to read dogs if the authentication is not null, and create an update if the request belongs to the user that is trying to write to Firestore. And in order to test this is quite simple. I have a function that I created, a script that I created here, which is in order to test the rules using the emulator. And if I run this, if I just put here npm run test, I can run both the test of my cloud functions and the test of my security rules. And we're going to see that it should be working as expected. Yeah, all of the security rules tests are passing, and the code is available. So you should be able to access all of this. It's in the test folder here, and the file is called rules.ts. And here we basically assert that a dog can be written or read in certain situations, and a dog cannot be written or read in certain situations. So all of this is passing. The tests of the cloud functions and the rules worked. And just to wrap this up, then I would say that there are some things to consider here. We used Firestore for this, but we need to filter data on the client side because we cannot filter Firestore data for dogs that have not been seen. So we need to get all the dogs and then filter for dogs that we have already seen, which is not great. And this limitation exists because Firestore relies on indexes for efficient retrieval. And this might be suitable for smaller datasets, but it can become inefficient for larger collections. So if this explodes and it's used in every city in the world, one of the things that we should do is maybe try to use another database, such as Firebase Data Connect, which is a relational database. And we can implement this feature very easily with GraphQL because we have a type dog that has an ID, name, and a string of dogs that I have already seen. I specify a query, which is dogs not seen by, and the string of a person. And then here, I just do some very simple code, which is getting all the dogs with a filter where the dogs doesn't include the person that is retrieving them. So that's one thing that I can do. And things to consider for Firebase Cloud Functions as well. You can, again, specify the region of your Cloud Functions. So the default functions region is US Central 1. So if our user base is located in Europe, we can change it to another region that will enhance performance in that specific region. And then we can also set a minimum number of instances with the min instance property in case we wanted to create a lot of instances that are always going to be living, and we can decrease the cold start time. Keep in mind that this comes with an associated cost, so be aware of this. Like if you're willing to pay a minimum amount of dollars per month, then this is a good option. Otherwise, it isn't. And then I guess now it's your turn. We have a lot of challenges that, we ran out of time on this workshop, but we want you to do, and we want you to send the results, and we should be able to provide feedback in no time, which is implementing the chat feature of this Team Dog. Right now, we have set up everything for you so that you can go implement the chat between two dogs, and you can tell us how it worked. And you can do that using Firestore. You can do that creating a UI that lets you push messages and receive messages. And we would love to know how you dealt with that. And if we can provide any sort of feedback on both the Flutter side and the Firebase side, we can do that. Any questions?
It was too much information, right?
Yeah. Okay, I think we can share lunch together. And if you have questions, we can.
Three hands, 2 hands.
Okay, we can stay. So whoever wants to stay with the questions, you can stay. And if you want to go get some lunch, thank you so much for being here. We appreciate it.